Hello and welcome to my YouTube channel. Today I am going to start a new playlist, and in this playlist I'll be covering some of the basic fundamentals related to semiconductor devices and circuits. Let me talk about the significance of this playlist, or you may say the significance of this course. A course on semiconductor devices and circuits is considered to be very important for those who are going to develop a career in electrical and electronics engineering, because such a course is considered to be very important in understanding, designing, and analyzing electronic systems. Apart from that, let me list some other key reasons why this course is significant. First of all, this course is considered to be the foundation for electronics. Semiconductor devices and circuits serve the building block for any electronic system. Devices like diodes, transistors, ICs all follow some basic rules and regulations, and these rules and regulations can be understood by going through this course. Secondly, if you are going to develop analog or digital electronic circuits, then this course will be very helpful and essential for all those engineers who are going to use circuits to develop computing and communication systems. It will also help you to understand the behavior of semiconductor devices like diode, transistors, MOSFET, or similar transistors. Apart from that, if you are going to study about integrated circuits or ICs, in that case, you know that ICs contain millions or even billions of semiconductor devices or transistors in a single chip. Understanding the semiconductor physics will help you to have a more in-depth knowledge about the ICs and their working. For example, if you consider microprocessors or microcontrollers, they are containing millions of transistors. So understanding the semiconductor physics will help you to understand the performance of microprocessors and microcontrollers also. Apart from that, if you want to develop a career in signal processing, if you know that signal processing is considered to be a very vital or important subject in electronics. So by knowing the semiconductor physics, you will be able to handle electronic signals and manipulate those signals for various applications, for example in medical or in defense. Apart from that, if you want to develop a career in power electronics, even in that case, this subject will help you in many ways, because even in power electronics, nowadays power supplies, motor drivers, renewable energy systems, these are developed using semiconductor devices, and understanding the fundamentals of these topics will help you to develop better power electronic or power electronics related systems. If you want to develop your career in communication systems, for example, telecommunication, radar, or mobile communication, in that case also, going through this course will help you to develop the fundamentals in communication systems also, because even in that case, if you are going to use amplifiers or mixers or modulators, then semiconductor devices and circuits course will help you to understand the working of those amplifiers and modulators. Apart from that, nowadays new emerging technologies are also taking the help of semiconductor technology. For example, nanoelectronics, quantum computing, and other cutting edge technologies are all built around the semiconductors. So, therefore, these technologies will be also helpful if you have very good knowledge in the semiconductor devices and circuits. Apart from that, if you want to pursue a career in electrical engineering, electronics engineering, or any related field, then a strong foundation in semiconductor devices and circuits is considered to be very important. Therefore, this subject will help you in all these domains. Now, let us start the basic fundamentals of semiconductor devices, or how can we start studying about the semiconductor devices. For that, we have to understand the physics behind the semiconductor devices. So, first question that should come to your mind is, what is a semiconductor, and what is the difference between different types of semiconductors? Conductors versus semiconductors, insulators versus semiconductor, and so on. So remember, semiconductor comprises of two words, semiconductor. So any material that has electrical conductivity between a conductor and an insulator is considered to be a semiconductor. So any material that has electrical conductivity between conductor and insulator are considered semiconductor. Secondly, the benefit of using semiconductor is that by introducing some impurities in these semiconductor devices, or by bringing some defects into the crystal structure of these devices or materials, we can change the conductivity. That means we can further improve the conductivity of semiconductors by introducing impurities. So that means the best thing about the semiconductor is that the conductivity can be varied, whereas in case of conductors or insulators, we cannot change the conductivity. In general, silicon is mostly used in designing or developing integrated circuits or ICs. So, in general, silicon is the most commonly used semiconductor in today's market. But apart from silicon, there are many other semiconductor materials, like you have germanium, you can use gallium arsenide, you can use indium phosphide, and so on. And by changing these materials, again we can change the conductivity of these semiconductors. In short, if we consider this graph on right, you can see on top we have the metals, which are considered to be the conductors, and their conductivity ranges between 10 to the power 4 to 10 to the power 8. These are very highly conductive materials like copper, silver, iron, aluminum. So these materials are considered metals. Remember, the number 10 to the power 4 to 10 to the power 8 is the conductivity. Second, we have semiconductors. Their conductivity ranges between 10 to the power minus 4 to 10. Examples of semiconductors are silicon, germanium, and we will be covering more semiconductors in the coming slides. Third, we have insulators, and their conductivity varies between 10 to the power minus 24 to 10 to the power minus 8. So, in short, we can see that semiconductors conductivity ranges between 10 to the power 4, 10 to the power minus 4 to 10. And remember, these are the conductivity of pure semiconductor. And by introducing impurity, we can change the conductivity of semiconductor materials. So, what about the electrical conductivity? Conductivity in general is measured in Siemens per meter, or we can consider ohm meter, or we can say it mho per meter. Some other ranges of electrical conductivity for semiconductor materials can be listed like this. If you have a pure semiconductor, then we will call them intrinsic semiconductor. So remember, pure semiconductors are intrinsic semiconductors. In general, they have very low conductivity. But if you increase the temperature or if you introduce some impurities, these conductivity can change. But in general, in room temperature, they have conductivity between 10 to the power minus 7 to 10 to the power minus 3 Siemens per meter. Then we have extrinsic semiconductor, or we can call them impure semiconductors. So in case of impure semiconductors, the conductivity may vary between 10 to the power minus 3 to 10 to the power minus 2. So somewhere near the conductors. Okay, so by introducing some impurities, we call them doping. Okay, by doping, we can change the conductivity of pure semiconductors, and such semiconductors are called extrinsic semiconductors. There are two types of extrinsic semiconductor. One is called P type, other is called N type. We will come to these topics in the upcoming slides. What are P type, what are N type semiconductors? Remember, even in case of doped semiconductors, the conductivity may change by changing the temperature of the semiconductor. Temperature dependence is considered to be one of the most important features of any semiconductor, be it intrinsic or extrinsic. So in case of doped or undoped semiconductors, changing the temperature will change the conductivity of the material. And remember, conductivity is directly proportional to temperature in case of semiconductors. So if you increase the temperature, the conductivity will also increase. Like I said, most commonly used semiconductors are silicon and germanium. And for silicon, the conductivity may range between 10 to the power minus 4 to 10 to the power 2 Siemens per meter. Now coming to the doping concentration. What is doping? Doping is nothing but introducing any impurity to the system. So by changing the impurities concentration in the pure semiconductor, we may change the conductivity. In general, we add some dopant atoms to these semiconductor atoms like silicon or germanium, and that will change the electrical property of the semiconductors. And these dopants are measured in per centimeter cube or per meter cube. Remember, when we dope, that means when we introduce impurities, Then we add dopant atoms to the pure semiconductor and we may create P and N types of materials. And if we combine these P and N type of materials, then we can develop diodes, and the amount of dopant that we add are generally calculated in parts per million or ppm. So doping can be low doping or high doping depending on the type of material that you want to develop. If you are considering low doping, that means adding low amount of impurities, then remember we add only one atom of dopant in the pure semiconductors 1 million atoms. So that means if I am taking silicon, which is a pure semiconductor, then I will take 10 to the power 6 atoms of silicon and I will add a dopant, okay, with only one atom per 1 million silicon atoms. So this is considered to be a low doping level. Even in this case, the conductivity changes. And this doping may vary depending on the specifics or the requirement of the device or the device like diode, transistor, MOSFET. These dopants concentration may vary and resulting change in the total electrical characteristics of pure semiconductor. So if we consider the periodic table, then where we can find the semiconductor materials. Remember, semiconductor materials can be found from these group of elements. In general, most commonly used semiconductors are from the fourth group. Okay, so this is the fourth group where you have carbon, silicon, germanium, and tin. So we have carbon, silicon, germanium, and tin, but most commonly are used silicon and germanium. And dopants are generally taken from third group element or fifth group's element most commonly, but of course nowadays we also use elements from group 2 and group 6. So if we consider the group 3 elements, then we can add dopants like boron, aluminum, gallium, and indium. If we are considering to add dopants from fifth group, then we generally add phosphorus, arsenic, and antimony. So remember, these are your dopant, and here we have the pure semiconductor. So depending on the choice of material, we may add dopant from third group or fifth group with the elements from the fourth group. We will come to these topics in more in-depth manner in the coming slides. Now, like I said, we generally use silicon and germanium from the fourth group, and then we add elements from group 3 or group 5 as a dopant to change the conductivity of pure semiconductors. Apart from that, we may add elements from group 2 and group 6 to change the conductivity of elements from group 4. Some of the examples of such combinations are gallium arsenide and zinc sulfide. So depending on the type of, or depending on the number of elements that we add, we may consider different types of alloys. For example, if we are going to use only two types of elements, then we will call them binary. If we use three different elements, or if we combine three different elements, then we may call them ternary. Example, aluminum gallium arsenide. If we want to add, or if we add four different elements, then we will call them quaternary. Example, indium gallium arsenide phosphide. And then even we can add five different elements to develop semiconductor devices. So based on the number of different elements, we may categorize them as binary, ternary, quaternary, or penternary. So applications of these semiconductor devices in general are, for example, in case of binary semiconductor, these are used to develop integrated circuits or ICs, which are generally used in digital electronics, computers, smartphones, or to develop power devices like diodes or transistors and so on. Even they are used to develop photovoltaic cell like silicon solar cells, which converts solar power to electrical power. Applications of ternary semiconductor materials, for example, aluminum gallium arsenide or indium gallium nitride, they are generally used to develop high frequency electronics. That means devices which are generally used in very high frequencies, or we can call them microwave applications. Even ternary devices are used to develop optoelectronics. Opto means light. So electronics which are relevant or related to lights are generally developed using ternary semiconductors. So for example, LEDs are developed using ternary semiconductor materials. Apart from that, lasers for telecommunication and optical communication, they are actually developed using ternary semiconductor materials. Even solar cells also uses ternary compounds nowadays. Now coming to quaternary semiconductor materials, example is aluminum, gallium, indium nitride. Generally, these are used to develop fiber optics, advanced photodetectors. Photodetectors means detecting different colors of light or different types of light. They are also used to develop lasers, which are used in telecommunications and medical applications. Fourth, we have penternary semiconductor materials. Example, indium gallium arsenide nitride antimony. These are very rare in the market nowadays because penternary semiconductor material or devices are very difficult to develop, and nowadays new inventions are taking place where penternary semiconductor materials are finding their applications. They are generally used to develop LEDs. They are generally used also to develop highly efficient solar cells and wide band gap semiconductors, which are generally used in high power applications or high power switches and so on. With this, I would like to end the video. If you have any suggestions, queries, then please post your queries and comments in the comment section. If you have not subscribed the channel, then I would request you to please subscribe the channel and press the bell icon so that you will get the latest video uploaded from my end. Thank you for watching this video. Have a nice day.